today. Now, we've already talked about this. What is the perfect square? We did a chart, but I'm going to give you a complicated definition. The product of a rational number multiplied by itself. Okay, so like 7 squared equals 49. 49 is a perfect square because it's 7 times 7. Okay, so we would say this is a perfect square. See, that's why negative 49, it's not a perfect square, is it? Give me two identical numbers that multiply to negative 49. There isn't. There's negative 7 times 7, but those aren't identical numbers, so it's not a perfect square. Okay? How about 0.09? Is that a perfect square? Yeah, because that's 0.3 squared. 0.3 times 0.3 is 0.09. So you can take the square root, and when you're getting an irrational number, like the square root of 10, right? Well, that number that you get, 3 point whatever times 3.1, right? That'll give it to you, but like that's not a rational number. So that's why it's not a perfect square. Now, a square root, so square root of x is a number r such that r squared equals x. So it says the square root of x is a number r. So what am I trying to say? Well, the square root of 49 equals 7. So this is x and this is r. Now, is r squared equal x? Yeah, so it does 7 squared equal 49. Yeah, that's all that's saying, right? R squared equals x. Square root of x equals r. Now, we already talked about the number 81 is a perfect square because 9 squared equals 81, or the square root of 81 equals 9. Okay, the square root of 36 is 6. The square root of 49 is 7. Now the square root of 132 is 11.4891259 ... So this is not rational. Therefore, not a perfect square. See, this is a perfect square. Okay, so let's just, okay, what's A? Yell them out. B, C, D, E, F. So that one you should, hopefully you're going, that's not a perfect square, is it? So close to 4. So what's the best one? There's square root 16, or there's square root 25, right? It's in there somewhere. And it, you know, so we put little squiggle, and that's around 4.5. Square root of 44, right? 7 times 7 is 49, right? So it's around, but it should be less than 7, right? So about 6.6, 36, 0.09, 0.3, square root of 0. Okay, students think can't do it. Yes, you can. Square root of 0 is 0. Square root of negative 25. Okay, so we go like this. It's an empty set, a 0 with a slash, and it's an up and down. I didn't do that very good. It should be pretty well up and down. Okay, looks like an olive. Square root of 65. What's the best one that you know? So you're thinking 64. So it should be more than 8 or less than 8? More. So that's about 8.1. Okay, now how about, before you, I want to, what if I gave you this? 6 root 14 minus root 7 all over 4 root 5. So that one's like weird, hey? Like it's, but how would you do it? How could you do it then? Yeah, put in a calculator, but make sure you put brackets around the top, or else it'll just take your second number and divide by. And if there's, you know, put brackets in the bottom if there's 2 more of those. So see what you get. 6 root 14 minus root 7 over 4 root 5. What would you get? Go to like 2 decimal places. So we'll do a little squiggle, because I bet you it's not going to be nice. What are we getting? 2.22? 0.21? Okay, so you should be so you got 6 root. Whoa. Hit the wrong thing. Okay, and you see, for my calculator, I always have to shut the door there of the that's what I get, 2.21. Okay. Okay, so okay, so what's the moral of the story? Well, you know, some of these, make sure you have an idea of what it should be when it comes out, right? Sometimes they're just so complex, but we do still have to have that in mind. Okay, now a square has an area of 169. Determine the perimeter of the square. Now this messes with people's heads. When they get into 2 different dimensions, because surface area or area and perimeter are very different. Okay, so if you had a square now, if it says I have 169, that's my area, correct? Therefore, what would my perimeter be? How much? 52. Now people are like, what? How did you make? Okay, well, first of all, what's my length and width? Because area equals s squared. 169 equals s squared. I need to solve for s. I will take the square root of both sides. You put plus minus 169 equals s. You'll get plus or minus 13 equals s. Now for us, dimension should have a positive. Okay? So we're going to say it's plus 13. So then we go 13, 13. And my most common answer for this, most common wrong answer is 26. Okay? Because what do? Just add the length and width together. But perimeter is all the way around. So then we should be doing perimeter equals 4 times s. Perimeter equals 4 times 13. Perimeter equals 52. Okay? Now, we haven't talked about a perfect cube. So a perfect cube would be like 8, because it's 2 times 2 times 2. 3 identical numbers multiplied. Another perfect cube is negative 8, because it's negative 2 times negative 2 times negative 2. Okay, so how do we figure that out? Well, we put the cube root of 8 equals 2. Oh, that 3 should be up here, little guy. Or the cube root of negative 8 is negative 2. You can take the cube root of negatives, like on your quiz today. You cannot take the square root of negatives, because there's no two identical numbers that multiply together that'll ever give you a negative. If you come up with them, you would probably be a millionaire, because you've come up with the only one. So we say that the cube of 8 is 2. What's the cube root of 64? It's 4, because 4 times 4 times 4, right? Now, don't get mixed up, because the square root of 64 equals 8. And remember, when there's a square root is so common, but there's actually an invisible 2 there, but you'll never see a 2, because square root, it's assumed it's a 2. Okay, cube root of 125, 5. Okay, cube root of 729. Okay. What is the square root? So we did the cube root. What's the square root? 27. Oops. Now, it is kind of interesting to see why it has a perfect cube and a perfect square. Okay? Well, let's factor it. And what I'm going to use is what's called like a factor tree or a factor chart. You put 729, and what you want to do is pick a prime number that goes into it. And 3 goes into it, and you'll get 243. Okay? Now, you know the trick to know if something is divisible by 3? Add all the digits up. 7 plus 2 is 9. 9 plus 9 is 18. 18 is divisible by 3. Therefore, 729 is divisible by 3. Okay? You know 18 is divisible by 3 because 1 plus 8 equals 9. 9 is divisible by 3. Okay? So if you're given a 10-digit number and someone says this is divisible by 3, add all the digits up, and then you can say yes or no. And like 27, or actually 729, when you add all the digits up, you get 18. When you add all those digits up, you get 9. Right? So you can even add the digits up from your answer and see, to get a smaller one, is it divisible by 3? Yeah. Okay? If you know it's divisible by 2, just look at the last digit. If It's divisible by 5. Let's see if it ends in a 5 or a 0. Right? Okay, so 2 plus 4 is 6. 6 plus 3 is 9. So I know this is divisible by 3. And I get 81. 8 plus 1 is 9. I know that's divisible by 3. And I will get 27. 2 plus 7 is 9. So I know that's divisible by 3. And I get 9. I know 9 is divisible by 3. And I get 3. And then do it one more time till you get a 1. What's that? Well, now I have 2 sets of pairs, and 3 times 3 times 3 is 9. So that's, right? Or sorry, no, that's 27 times 27. So that's why it's a perfect square. But I also have 3 sets of 3s. So that's why I get 9 times 9 times 9. So this is why it works for both. It has perfect squares and perfect cubes. Now, methods to find out square roots is prime factorization. That's what I just did. Does anyone know what a prime is? 1, 2, 3, 5, 7. What's the next one? No, before that one. 11, then 13. Dot, dot, dot. They have no factors except for one in themselves. You can't, like 6, 3 and 2. Right? 8, 2 and 4. 5, nothing. Divide by 5. 1 in itself means it's a prime. Yeah, I mean 1 works for everything. So prime factorization is what we did there, all the 3's. Okay, a diagram. Now a diagram is when you have 9 and you go like this. That's 3 times 3. Now if you had 27, you would go 3 times 9, 3 times 3 times 3, right? That's your diagram. Your tree diagrams, they call them. And everybody's favorite, the calculator. Okay, and you should have seen all these ways through math. Okay, so like we said, prime factors. Oh, actually, sorry. Get rid of this one. That's my bad. Okay, 1 is not a prime. 1 is neither prime nor composite. Okay, prime stands for any number that can't be divisible by anything but 1 in itself, and non-prime are called composite. So examples of prime: 2, 3, 5, 7, 11, 13. What's after 13? 17, then 19. Composites, 1. Well, 1 shouldn't even be there. Okay? So 4, 6, 8, 9, 10, dot, dot, dot. Okay, so I don't want to beat this to death. So let's just use prime to see if they're perfect squares, perfect cubes, or both. Okay, we did one like that already. Let's do 216. Okay, 216, since it's even, I know it can divide by 2. That's 108. I can divide by 2 again. That's 54. It's still an even number, so I can divide by 2 again. That's 27. Okay? And then, now I can divide by 3. I get 9, 3, I get 3, and then 3 again, I get 1. Okay, now, yep. Yep. That's when you finish. Now, you don't want to go, okay, 2 times 2 times 2 is 8 times 27, right? 8 times, like, you know, yeah, 8 times 27 would give you this, but that's not, right? So how do we take this information and actually see if it's a perfect cube or a perfect square? What's that? Okay. So for cube, we want to see if we can do 2 identical groups. Or no, 3 identical groups, sorry. So I can do a 2, 3, 2, 3, 2, 3. So I have to use them all up. So those are 3 identical pairs. Now if there was one more 3 here, I'd have a 3 left over. I couldn't do it, right? So everybody has to get used up. So I used, right, these 2. So then I just have to, it's 6 times 6 times 6. Now for a square, I need to make 2 identical groups. Now can I do that? Give me the 2 identical groups. I can't. So can't in this case. Yeah, that big. Well, no, I need 3 identical groups for cube. I need 2 identical groups. So why don't I do 144? Let's see what that's going to do. So 144, I put a 2. I get 72. I'll put a 2. I get 36. I put a 2. I get 18. I put a 2. I get 9. I put a 3. I get 3. I put a 3, I get 1. Okay? So, can I do 3 identical groups? No. Can I do 2 identical groups? Okay, what would be my 2 identical groups? 2 times 2 times 3 and 2 times 2 times 3. Okay? And make sure everybody got used up. 2 times 2 times 3, 2 times 2 times 3. Okay. And then you get your 2 times 2, 4. 4 times 3 is 12. That's 12. Okay, so that's a perfect square. No, they have to be identical groups. So you've got a 2 times 2, a 2 times 2, and a 3 times 3. That is not. Now, this is the factors of it, but it's still not a perfect square, or it's not a perfect cube, because you need 3 identical groups. Okay? Okay, now I'm not going to lie to you, I never use this way, ever. Okay? Because I've taken the time to know my perfect cubes and my perfect squares, and I'll show you where that will serve you well, because you do have a calculator, so the rest works for you. Now, here we have volume. Volume is 3-dimensional, and that's why it has a cube. So, volume equals x cubed, right? You got x, x, and x. So, I have 125 equals x cubed, because it told me my volume. Now, how do I make x cubed into x? take the cube root of it. So here you need to take the cube root. Now you know it will be a positive. It's not like squared. Squared can be positive or negative. But this will give you 5 equals x. So that means this is 5 by 5 by 5. Okay? Now, how do you put this in your calculator? It's the first button you need to press. So you hit Math, number 4, and then obviously put in 216, and then enter. Now, again, these will serve you the most if you have them known. Okay? When you get square root 26, if you're hemming and hawing, if that's a perfect square, you're really going to struggle in this unit. Okay? And I'll show you why it is so vital. So if you're struggling in this, you need to get that x squared chart and that x cubed chart and have your parents, have somebody just keep asking you till you know them. And this will be a very easy unit for you if you do that. If you never do that, you probably will not pass this exam. Okay? So you get to decide how you're going to do. Because yes, if you're not good at them right now and you haven't put in the work prior, you need to now. Okay? What is the cube root of 8? 2. Cube root of negative 64. Negative 4. Cube root of 27. 3. Can it be negative 3? No, because that would mean it was negative 27, right? Okay. Cube root 1. Now, this one says determine if they're perfect cubes, squares, or both. 125. Is there a perfect square or perfect cube? So we'll put a 3 there and we'll get 5. 64. Perfect square and cube. $216. That is a perfect cube. 729. Okay, this is both. Because the square root equals 27 and the cube root equals 9. Okay, 4096. This one's both too, because the square root of 4096 is 64. The cube root of 4096 equals 16. Okay, now this one, 1 million. This is both as well. The square root of it, I won't write it all out, is 1,000. The cube root is 100. Okay, and then there's some other roots. Now you can be putting them into your calculator, always test, but square root of 16 is 2 times 2 times 2 times 2. So there is a group of 4. So the answer is 2. The fifth root of negative 32 is negative 2. And the fourth root of 81 is 3. Now, why am I stressing your perfect squares and perfect cubes so much? It's because soon we will be at a stage where your calculator will not help you. Okay? So, an example. If you put the square root of 50, okay, what's the square root of 50? Put it in your calculator. I want to know it. It's irrational. Okay? If you were to write that down, it says in math, you always have to leave everything as an exact answer and simplified. If in Math 31 or Math 30, if you left your answer as square root 50, you'd actually get it wrong because it's not simplified. But you can't put that decimal down, so you have to simplify it. Now what that means you have to get all of the perfect squares you can out. So what you want to do is you want to have factors in, so it's, I don't do it this way. Okay, I'm not talking about this. You can do it this way, but it's very painful. If you know your perfect squares, this isn't so painful. But what two numbers multiply to 50, one of them being a perfect square? 25, right? So this is the same thing. That's a times sign, okay? You see, these two are identical. So we get in the habit of putting this into its factors, one being a perfect square. Now how do I know this is a perfect square? Because I memorized them. Okay, I know it's an ugly word in education, but man, you have to know your times tables. You have to know your alphabet. You have to know your punctuation, right? There are the basics. Nobody knows their basics. Nobody just knows the alphabet like they're born. They know the alphabet. They had to memorize it. Okay? And same with times tables, same with perfect squares and perfect cubes. See, now, what's a square root of 25? So what you do is you do take the square root of 25 and you bring it outside. Now that is the simplified exact answer. Yep. Okay, that's a good question. So if I had 3 root 50, this would become 3 root 25 times 2. The 25 comes out to become a 5, and 5 times 3 is? Okay, so a 5 came out, and 3 times 5 is 15. Yes? It is saying 15 times the square root of 2. Yeah. Now your calculator knows that. So you can go 15, because this is how you can always check your answers. 15 square root 2 is 21.21. Or you can go 15 times square root of 2. What? Well, 3 root 50. Oops. Yeah, I can show you how. Well, that's a little bit harder. But do you see how they all mean the same thing? Because these are all the same thing. The problem is, this one isn't finished. It's kind of like if you left, remember how you always used to get that wrong? Everyone's like, come on, did all this work and I got 4/8. Why is it wrong? Because you got to reduce it, right? With radicals, you must always get as much out as possible. Okay? So if I was to do the square root of 72, well, it's not a nice number. But this is the same thing as the square root of 36 times 2, correct? 36 comes out to be a? Okay, so it's all about simplifying. Okay, the square root of 75. Now that's not a perfect square. Like if you're wondering if 75 is a perfect square, you don't know your perfect squares yet. You need to do it. But you get, and with practice, this is the same thing as 25 times 3. 25 comes out to become a? Okay. Yep. No. 6 is 6. It's on the outside. Okay. And there's weird things too. Like say you had, square root 32. Well, what are two things that multiply to 32? 2 times 16? 4 times 8? So that gets weird now. Okay? So Can I do your way first? Now, I always put the perfect square next to the door because it's getting the boot. I don't go 2 times 16. I go 16 times 2 because I'm getting it out of there. And that becomes 4 root 2. Now, what did you say? 4 times 8. The 4 comes out to become a... Now, some people would say those aren't the same, but I would say you're not done this one yet. Is there another perfect square still in there? This is the same thing as 4 times 2. The 4 comes out to become a 2, and the 2 times 2 is? Okay, so you will get there. Maybe there's way more than one way to get to school here, trust me, right? But if you all follow the directions, right, that you've been given, you'll get here, okay? So this person that put a 4 here and they get 2 root 8, they're like, oh, I can't get these. I wouldn't have seen the 16. And I go, no, that's good, but you've got to keep going if there's still another perfect square in there. Okay? So this is where we're going to be going to, right? And you have to know your perfect squares and your perfect cubes, okay? So I did these with you already. So I want to do LCM and GCF. You've heard those forever, okay? Especially when you're adding and subtracting fractions or that's probably the most times you ever did it, right?
Need me to break the...
Okay, we'll start from the beginning. Let's go to the first page. I thought you actually had Concordia students in here. That's coming. That's why I was.
Well, you know what's a funny story? There's about 4 of them that showed up this morning. They just go to Highlands, but they all came here and they actually wanted to stay.
There's some disappointed Concordia students this morning. I bet 4 of them anyway. Okay, so LCM and GCF. Remember we did the 2 charts. Now who remembers the difference between them? Because they're similar. One does the L for the LCM. GCF does the side. But was there different rules when we did them? Which one can you drop? LCM, right? So LCM you can drop. GCF, there's no dropping. You have to go into all of them or you're done. Okay? So let's do the LCM. We got 15. We got 36, and we have 48. Now again, don't get lazy. See if you can go into all of them, because that's what you have to do first. Okay? Is there something that goes into all of them? 3. And remember the trick? 1 plus 5 is 6. 3 plus 6 is 9. 4 plus 8 is 12. So they all must be divisible by 3, right? And you see how fast you can check if you just know that little trick? So we go 3, and we drop our 5, drop our 12, and drop our 16. Okay? Now, is there a number that goes into all of them? Okay? Now, if there's 5 of them, you got to see if we can go into all 5. Next, don't jump down to 2. See if you can go into 4 of them. Then 3 of them. Then 2 of them, right? Now this one, we can't find anything that goes into all 3 of them. So we can drop which one? So if we drop the 5, we still have to do some work with the 12 and the 16. So what are we doing? 2. We got 4 or 2. Okay? We can arm wrestle. We could, if we do 2, we're going to do one more step. But if we do 4, then we get our 3 and our 4. So if you would have done the 2, you would have just had one more thing to do. Okay? So again, we go. Now, is there... Okay, so really, if I have to drop 2 of them, I'm not really finding anything, right? So, I'm done at this point, okay? If you can't find anything that goes into even 2 of them, you're done. Now, the thing is, I guess I shouldn't have drawn this. I should have seen, is there something I could put into them? And again, if you would have went 2, you would have had another 2. And still get that 4, right? And then we just multiply our L together. Okay, and what do we get? 720. So that means that is the smallest number possible that all 3 of those will go into. Yep. No, you can keep, because if I could just do it differently, I got my 15, 36, and 48. So that'll be my 5, my 12, my 16. So I did a 2 because I'll drop that, right? So my 5 got dropped, and then that became 6, and that became 8. Now look, I can still go into these 2, so I will drop that one again. Okay, and then I do my 2, and I got my 3, and I got my 4. Now do you see how we will still get the same L when we multiply? But I dropped it twice, and that's a good question. Yeah, you can drop it more than once. In fact, it could get dropped 3 times, 4 times sometimes. Especially since this is a prime. Primes will just get dropped, right? You're not going to find anything. Now, I guess if this would have been 5, 10, and 15, I could have went 5 into all of them. So I guess primes don't always get dropped, but okay. So we get 720. So just remember, for the LCM, we do the L, and you have to try all first. If not, you can drop 1. Okay, now GCF, I want the, so this is how, because my students always got this mixed up. So we have the M and the F. Okay, so I would always talk about, I would go find mom. Okay, when in doubt, always go find your mom. So, and it's these 2 letters I'm talking about. Factors are what go into numbers. Multiples are what come out of. So when I say, what are the factors of 8? The factors of 8 are all the things that go into 8. So an example, 8. I'll say find the factors of 8. And another question, I'll say find the multiples of 8. And students are like, oh, I always get those mixed up. Like, I don't know what you mean. Well, the factors of 8 would be 1, 2, 4, and 8. See? These are all the numbers that go into 8. I made this up myself, by the way. Patent pending. Okay? Now, out of. The multiples of 8 are 8, 16. What's the next one? 24, 32, ... See? Multiples are what come out, out. So when I ask for the multiples of 8, I want what comes out of 8, 8, 16, right? Factors go in. Find mom. Okay? You won't mix those up. Because if I just ask someone out of the blue, okay, give me the multiples of 64, they're like, oh crap, which one was that again? Okay? Find mom. Okay? Now, GCF, factors, greatest factors that go in. Now we use the same chart, but we don't use the L and we can't drop. We use the side. Okay? So we got 84. We got 294. We got 882. And like I said, I was taught this method like 25 years ago by a math teacher, and I can't believe how many math, like nobody, I'll show other math teachers this all the time. They're like, I've never seen that before. And we had 2 ladies from Africa, and they use this method in Africa, right? Does that work? Yeah. So it's not a North American thing. And so I'm not taking any credit for it. I hope you're getting that straight, right? That teacher that taught me, I was like, wow, that's pretty cool. But it was at a good time before I was teaching this stuff, right? But even, come to a new school and I'm like, hey, you can use this chart, right? They're like, wow, I've never seen that chart before, right? They go like, trust me, when you're doing these, this is horrible. Like 15, you got to do all the multiples of 15, right? And then you got to do all the multiples of 36, and then you got to do all the multiples of 48, and then you got to find out what do they have in common. Like it's like, torture, right? This, it is very compact. It works all the time if you know the rules, right? And some teachers will try this and go, it doesn't work for this one because, and I'll say, oh no, you're allowed to drop one. They're like, oh yeah, I forgot about that, right? So now, GCF works really, really well because it has to work on all of them or it can't work, okay? So these are all even. So pick 2s and 3s. Like I don't even recommend using 4s. 2, 3s, 5s. That's going to get you through 99.9% of these. Okay, and then 7s and maybe 13s sometimes, right? Because there's some weird numbers. So you just chop it down. So I put in my 2, I get 42. And yes, you can use your calculator to do these. 441. But you want fast references of 2 and 3s. 2s, are they all even? 3s, add them up. If they are multiples of 3, they work. Like 18, 1 plus 9. Right? Okay, now look. 4 plus 2, 6. That one's divisible by 3. 5 and 7, 12. That's divisible by 3. 4, 4, 9. That's divisible by 3, so I know they're all divisible by 3. Okay? Add up the digits. 4 plus 4 is 8, plus 1 is 9. Yes, that works. Okay, that's your fast way to check. So you get 14, you get 49, and you get 147. Okay, so must go into all, right? We want to and trust me, in 3 months when you have to write a final and you're like, oh crap, I forget the rules, I got it mixed up. You read over your study sheet, 5 seconds later you'll get it again. Okay, 14, 49, and 147. Now 14 and 49, I'm thinking 7. 147, does it work? So you try it quick, yes it does. And you will get 2, 7, and 21. Okay, so then I get students, they'll go like this, they'll drop and they'll put a 7. Can't do that. Okay, no dropping. Okay, so I'm done. Now, some students like to say, okay, so then they'll put a 1 and then they're done. I'm like, well, I just skip the middleman, I don't put the 1. But whatever, whatever floats your boat. And then you multiply them together. 2 times 3 times 7 times 1 is 42. 42 is the greatest thing that goes into 84, 294, and 882. And again, these are extremely arduous without the chart as well. Okay? I'm not even going to show you how to do it without the chart because it is just too time consuming and messy. And the more steps, the more chances for error. Okay? So, make sure you've got on your study sheet, right beside each other, for LCM, for GCF, rules, right? Because the charts I don't think you will struggle on, but will you mix up? Okay, and remember, find mom. Factors are what go into. And multiples are what come out, right? So I know if I say, what are the multiples of 12? I'm going to get some people saying 1, 3, 4. I'm going to go, no, those are numbers that go into 12. Those are called factors. What comes out of 12 are called multiples. Okay? The most dangerous stuff in math are the things that are so similar because they get mixed up, and you could do a whole test with that one mix-up. And I think we can figure out how that goes, hey? Okay, any questions? Lots of stuff today, but make sure this would be a good weekend to come on Monday, making sure you know what your perfect squares and your perfect cubes. Okay? And you have that chart from last day, right? We went through them all. And just so, like, You're like, well, I don't have to memorize them. I can use my calculator. Well, it's not going to work for you when I give you 72 and you don't even realize 36 is a perfect square to even start dividing. Now, that's going to be the issue with some people, right? I'll be able to find out right away you don't know your perfect squares. Now, what about square root 100? That's 10, you know that. But what if you're like, so we just say that's 10. But what if you went like this? Square root of 25 times 4. Okay, this becomes what? 5 root 4. What's root 4? Okay, so there's more than one way to get there even. Some people will go right here. Some people will go this direction. Right? Neither is wrong. Neither is more right than the other one. But the important thing is if you're following the instructions for you that work well, you should get to the same place as another person doing different instructions but correct. Right? Shouldn't you all end up at the same place? Yep. I'm actually busting out the 25. The square root of 25 is 5. So I actually bust it out. I take the square root of it. Now if you had square root 75, that's square root 25 times 3. That's 5 root 3. I can't bust out the 3. I can only bust out perfect squares. Okay, this is like jail right here. Here's the bars. I can bust out perfect squares, but I can't bust out anything that's not. Okay, so I've given you kind of a prelude. We haven't started obviously doing these yet, but that's where we're going. Okay, so why don't we put everything under our desks and maybe we can get some tests back. Okay, so clear your desks so there's nothing on them.